Hi, I'm Jeff with 101 Memory Lab. Many of you have probably heard about the high performance, super low latencies, and the increasingly high capacities you get with SSD drives today. Some of you have maybe also heard that the key component inside these drives is a NAND flash IC. What you probably have not heard is that there's actually a quality variance inside these chips. And it's not as straightforward as you may think. Now, inside these SSDs are actually two of the most fundamental components. One is the NAND flash controller, and the other is the NAND flash IC that I was alluding to earlier. So let's take a look at this Lego block as an example of your NAND flash IC. So in this example, you can see that there's various colors here. Green going to yellow, going to red. Now, NAND flash is organized in pages and blocks. So for simplicity's sake, in this example, in this Lego, let's just say that each one of these blocks is a NAND block, okay? You can actually see that throughout the actual chip, there's even grades of different quality in terms of each block. Your NAND flash controller actually has a very powerful error correction mechanism so that once the data actually comes out of the NAND through your controller, once you actually see the data, it's all good. But underneath this controller, there's actually, you can see, lots of different colors, lots of different quality. You know what? Let's go to the whiteboard, and I think I can explain it again more clearly. All right, so let's assume that this line here represents quality. And from our analogy that you saw from the Lego blocks, you have green, yellow, and red. So your error correction mechanism inside the flash controller, let's say that it can cover this much. So if it can cover this much, then actually green, yellow, and red is all covered. But don't forget that actually NAND flash has a wear. You can actually wear it out as you're cycling it. So when you say cycle, you're programming it, you're erasing it, you're using it. So the bottom line here represents product life. And let's say that your SSD is rated to live till here. So going back to our analogy, you saw one Lego block mostly green. So let's say, the blocks here look good, and it's making it well past your product life because your ECC engine has you completely covered. Now let's look at the yellow in example. Looks good, doesn't quite make it to the end of life. Now the red zone clearly won't make it to the end of life. Now, actually in reality, the red, we can assume, is actually covered. Because the NAND flash makers, when they send the NAND flash IC when it's brand new, they send you an original bad block map. Let's assume those are all the reds. So the issue actually comes with the yellows. The yellows maybe are not marked as bad from the manufacturer, but you can see they still don't quite make it to the end of product life. All right, so I got my Lego blocks again. So again, hopefully your blocks look like this most of the time. They're all green. The issue is still you have yellows in here, right? But it's assuming that even if you have a yellow, your NAND flash controller also has a very special way to manage these blocks. Now, the real problem comes if you have a lot of yellow, too many yellow. That means that your data actually is already getting into a corruption area. You don't have enough good blocks. So how do you know if you have mostly green, if you have mostly yellow? This is a big problem in terms of the whole life reliability. So check with your SSD manufacturer. Ask them how they guarantee that you're mostly getting green and that you don't have too many yellows that will cause your SSD lifetime to be actually cut short. If you like what you saw here today on 101 Memory Lab, please click here to subscribe. Lots of awesome information coming your way for flash memory and DRAM technology.